Hi everyone and welcome back. So today we're going to look at 3.5. This is graphing proportional relationships, and this can be found on page 212 of our textbook. Go ahead and put your name at the top, your class hour, and today's date. And let's take a look. So today we're going to be graphing some stuff. So again, we're going to be switching gears a little bit. This builds off of the last one. All right, it's pretty simple as well. And let's look at our goals for today. So what are we going to learn for today? We're going to identify proportional relationships. Identify proportional relationships. And then we're also going to analyze proportional relationships. Analyze. Big word. Analyze. Okay. So first we're going to just identify it. So figure out, is it proportional or not, like we did last time. But this time we're also going to analyze that. So we're going to kind of come up with some other things as well. Okay. All right. The first thing I have for you is what you really need to know for today. All right, and this basically dictates the rest of the lesson. It says if the graph of two quantities is a straight line through the origin, then the two quantities are proportional. Okay, so what that means is when we graph these things out, it has to make a straight line. Straight just meaning like it has to be going up. Okay, it can't zigzag, so it can't go up and then down and then like straight across and then whatever. Okay. Has to be a straight line. All right, it's going to be diagonal all the time, obviously. Okay, it has to be a straight line though, and then it has to be it has to run through the origin. Okay, so if you don't remember what the origin is 0, 0. Okay, you guys talk a lot about the origin in science class with your graphing in there. Okay, so it has to be a straight line and pass through that 0, 0 mark. If it doesn't, it does not work. Okay, it does not work. Okay, let's take a look here at the first one. It says determine whether each relationship is proportional by graphing on the coordinate plane. Explain your reasoning. Part A. The black mamba is the fastest snake in the world. The table shows the distance the snake travels for several different times. Is the distance the snake travels proportional to the time? All right. So for this one, we're going to just take a look. All right. So graph it if you need to. I don't have one of yours right in front of me, so I'm not sure if you're supposed to graph it. If it's not graphed, go ahead and graph it. Okay. So 0, 0 is right there. Remember, you go over first and then up and down. I always refer to the elevator. Okay. When you're going up and down an elevator, you got to walk across the floor, right? Across. So go across first, and then you ride the elevator either up several flights or down several flights. Okay. All right, then you graph out 1, 5, 2, 10, 3, 15, and finally 4, 20. Okay? All right, so with that being said, let's take a look. So does it meet the criteria that we just talked about? So go back up to the top. It says if the graph of the two quantities is a straight line through the origin, then the two quantities are proportional. All right, so is this proportional or not? What do you guys think? And yes, it would be proportional. And what are my reasons? Because it passes the origin. What's the origin again? That's 0, 0. That's right here. Okay? And it makes a straight line. So yeah, it's diagonal, but it's straight. It's not zigzagging and curving and all that kind of stuff, right? All right, so let's write that down. So this is proportional. Oops, that's supposed to be an L. Let's try that again. There we go. Okay, so it's proportional because it passes through the origin. Oops, not thought, thought. Through the origin and it makes a straight line. Okay, and that'll be your answer every single time. All right, so if it works, this is what you write. It's proportional because it passes through the origin and it makes a straight line. So it does get a little bit repetitive and redundant, but that's what they want, okay? Let's take a look at letter B. If you think you've got it, go ahead and try it on your own. It's not a got it question, but if you think you've got it, go ahead and try it. Let's see if you can get it. It says a candle is 20 centimeters tall. It burns at a rate of 2 centimeters per hour. Is the height of the candle proportional to the number of hours it burns? Okay, well, let's take a look. So, what's our criteria that we have to look for? Does it pass through the origin? No. Does it go through 0, 0? Does it make a straight line? Yes, it does make a straight line, but it has to meet both of them. So will it work then? No. All right, and this is where people like to look at the table and they're like, well, but it's a constant pattern. It's going 0, 1, 2, 3, 4, 20, 18, 16, 14, 12. It's going down by 2 every single time. Yeah, that's true, but that's not what it's asking us, okay? It tells us that it's proportional on a graph whenever it starts at 0, 0, and then it continues upward. All right, so this is non-proportional. Because it does not pass through the origin. Okay, so this one's non-proportional because it does not pass through the origin. This one can change. This is not always your answer. There could also be the other way, which would be it could have passed through the origin, but maybe it's not a straight line. So there's not one exact answer every single time. You just have to say which one it doesn't do. Now, if it doesn't do both, then you'll have to say both as well. All right, so if for some reason it didn't pass through the origin and it wasn't a straight line, then you would state both. All right, so just tell me specifically why it did not work. So it's not proportional because, and then tell me which one or two caused it to not be proportional. All right, let's take a look at the got it questions. So go ahead and pause it. It looks like you will have to graph some things out here if we haven't already. So let's make sure we pause and get all the graphing in and all that stuff, and then we'll come back and take a look. So I'm going to probably buzz through this one pretty fast, so definitely pause on this one. Okay, let's take a look. It says determine whether the cost is proportional to the number of items in each relationship by graphing on the coordinate plane and explain. All right, so again, you guys have worked on graphing in science class several times, so let's take a look here. So we have the number of tickets with the number of, or the amount of cost. All right, so let's call it ticket sales. All right, let's see, I'm going to label kind of every other one here. So this will be 0, 2, 4, 6, 8, 10, and then 12 will be way up here. That was cost and money. And then we're going to label on the bottom, so this will be 2, 4, 6, 8, 10, and this was tickets, number of tickets. Number of tickets. All right, so let's graph this thing out. Okay, so we have 2, 6, so 2, 6. We have 4, 8, so 4, 8. We have 6, 10, so 6, 10. We have 8, 12, so 8, 12. And then we'll go ahead and stop right there because we are going to run off the page. All right, so I need to make it into a line. So if I continue the line downward, okay, you can see that we're going to intersect right there. That's not given to us, but it will. All right, so would this one be proportional? The answer would be no, it's not proportional. And what was our reason? Because it needed to pass through the origin. All right, so this one's non-proportional. Oops, I can't spell. Ah. Okay, so it's non-proportional because it does not pass through the origin. Okay? All right. So let's take a look at this one. So this is number of hot dogs and cost. So this would be, let's see, we'll just do hot dog sales. We'll just kind of keep it the same way. Okay. Then we'll label each one again. I think every other one would probably be good. Yeah. So 0, 2, 4, 6, 8, 10, and we'll just leave that up there. That'll be okay. Let's see. Actually, no, that won't work because we got way too. Okay, let's back up. Let's count. Yeah, so we get up to 30, don't we? Let's see here. Let's count. Let's count by threes. So that would be 0, 3, 6, 9, 12, 15, 18. Let's see, 21, 24, 27, 30. And then we'll leave the last one up there, which is going to be 36. We'll just kind of hide it up here. There we go. All right, can we count normal on this one? Yeah, we can do just evens on this one. Okay, so 0, 2, 4, 6, 8, and 10. Okay, and let's label. So this is cost over here. This would be hot dogs, number of hot dogs. Down there. Okay, let's graph this out then. So we have 2, 6, 4, 12, 6, 18, 8, 24, and 10, 30. There we go. All right, so we need to connect our dots. And it looks like this time I would end up crossing the origin. So yes, this one will work. So this one is proportional. Oops, keep messing up. Proportional, there we go. Because it passes through the origin and makes a straight line. All right, so again, we just restate what our two criteria was. Okay, so it's proportional because it passes through the origin and makes a straight line. So one worked and one did not work. Okay, again, you can't go by the pattern in the tables. Everyone's like, well, it says 2, 4, 6, 8, 10. That's cutting up by twos. 6, 8, 10, 12, 14, that counts up by 2. So how come it didn't work? Because it's not proportional. Okay, we're not figuring out if it's a pattern or not. Okay, we're trying to figure out if it's proportional. All right, let's jump down to example 2. All right. It says the length of the stretch in millimeters of a spring is proportional to the weight in grams attached to the end of the spring as shown in the graph. Okay, so you guys should have your picture there. And then find and interpret the constant of proportionality. All right, well, what are our coordinates? We have 1, 5. So you think we should go 1 over 5 or 5 over 1? It says it's proportional. The length is proportional to the weight. So length would go first. So in this case, 1, 5. So it's actually the 5 and then the 1. So 5 over 1. And then we have 25 over 5. So that makes it 5 each time. All right. So if we're going to find and interpret the constant of proportionality, it's going to be 5. And that would be millimeters per gram. 5 millimeters per gram. All right, and then explain what these points mean. So what would 0, 0 mean? Well, we're just going to plug into the formula. So 0, 0 would mean 0 millimeters per gram. Obviously, if there's nothing, there's nothing, right? Okay, 1, 5, so we'd actually reverse it. So that would be 5, 1. So that'd be 5 millimeters per gram, which we just had. And then we would have 525, reverse that. So that's actually 25 millimeters for every 5 grams. Okay? All right, go ahead and pause it and try the last one, and then that'll be it for today. All right, let's take a look. It says Keith plants a seed every 3 days. After the seed sprouts, he measures the height of the plant. The graph shows his results. Find and interpret the constant of proportionality. Then part B says explain what the points 0, 0, 1, 2, and 6, 12 mean. Okay, so in this one, we're going to do, it says that the height is proportional to the day. So that means we'll do 6 over 3 and 12 over 6 and 18 over 9. Okay, and we get the answer of 2 every single time. So it means that that grows 2 millimeters per day. 2 millimeters per day. All right, then we need to explain what these mean. So 0, 0 would represent 0 millimeters per day. Let's see, 1, 2, so we'd switch it, so it would be, wait, where'd they get 1, 2 from? It's supposed to be 1, 2? I think they meant 3, 6, but that's okay. We'll use 1, 2, that's what they have. It's all right. So 1, 2, so that would be 2. Oh, that's the unit rate, that's where they got it from. Okay, so the 1, 2 would be 2 millimeters per day. And then finally 6, 12, so we would flip it, so it's actually 12, 6, so that would be 12 millimeters every 6 days. Okay. Alrighty. And there we go. I think we're okay. All right, that's it for this one. So thanks for watching, and I'll see you guys next time. Give me a thumbs up and subscribe.